Let us see the second problem in root locus. This was asked in GATE 2016 for 2 marks, and here we have to find the location of the breakaway point. Okay, so let us go and proceed. The forward path transfer function and the feedback path transfer function of a single loop negative feedback control system are g of s. Given the g of s here, okay, which has been okay. So for forward path transfer function is that's nothing but the open loop transfer function, or generally we call it as g of s. Okay, that's the thing. And of a single loop, there's only one single loop and negative feedback is given, and that is h of s is 1. Okay, unity feedback system and with a negative feedback. If the variable parameter k is real, it is real value and positive value, then the location of the breakaway point on the root locus diagram is what? Where is that? That's what we have to find. What is the value of what is the if what is the breakaway point? We are not finding k here, so then the location of the breakaway point on the root locus diagram. Okay, that's what we're going to find. Okay, all right, we're going to find the breakaway point. So let us have a understanding of a visual understanding of where the points would actually lie with the help of the poles and zeros. Okay, a arbitrary diagram of root locus, that will help us to solve this problem better. So coming to the zeros are the numerator, so you can say s equal to -2 is 1 0. And coming to the poles, I can use this minus b plus or minus root of b square minus 4ac formula for the denominator to find the poles. So here minus b is -2 plus or minus root of b square minus 4ac divided by 2a is this. So you get -2 plus or minus j times 1 divided by, because 2 by 2 will be 1, so this is oh, here also. So 1 plus 2 divided -2 divided by +2 is -1, and this is j root 4. So 2. I mean minus of the, you get -4, right? Root under -4 would become it will become j times 2. So this 2 and this 2 will get cancelled. So you get the poles like this. So two poles. The two poles are, let me write it downwards. The two poles are -1 plus j and -1 minus j. So now we got the poles and the zeros here. So let us arbitrarily draw the root locus diagram. Okay, this is the real axis and this is the imaginary axis. So the one of the zero is at -2 location. Let me call this as -1 location. So let me plot this. So if I call this as a plus j location, this is okay. This is the minus j location. Then my -1 plus j would be here, right? And the -1 minus j would be here. So okay, always the poles from the poles the locus would start. Okay, and at the 0 the locus would always end. Okay, first let us see where the locus exists on the real axis. Okay, for that let me take another color for indicating the locus. Okay, so here is there any poles and zeros on the right side of the S-plane over here? No. So there's going to be no locus on the right side of S-plane. Only if there are odd number of poles and zeros. Okay, only when there are odd number of poles and zeros, the summation of poles and zeros in the right side of wherever we are considering in the real axis, then the locus will exist. So here there will be no locus because there are 0 poles and zero zeros. And coming till here, it's going to be 0. At this point, it's going to be 2. 2 is an even number. 2 means 2 poles. 2 poles, so even number. No, there's going to be no locus on this real axis either. I mean, we're only talking about the real axis, not about these places. Only the real axis. That means this axis. Okay, this real axis. All right. I'm sorry, just remove that line. Let me put it back. It should be here exactly. Okay. So then here, okay, it's 2, no, but here 1 2 3, sum of the poles and zeros is 3, so there should be locus on the real axis from this point. And we always know the locus ends at 0 and starts from the poles. So it starts from the poles and somewhere it goes, because we know there's going to be no locus on this real axis because we saw it's 0 or even number. So it's not going to be, it's going to come here somewhere and it's going to go something like this also, because it's going to be odd forever. Alright, so what happens is that these two comes here and breaks away, and one of the things go to this 0, one of the poles, and the other pole, there is no other pole, there's no other 0 for this another pole. Okay, so it goes to the infinity. Okay, one of the poles goes to this 0, the other pole comes and breaks away and goes to infinity. Okay, if there are two poles, there must be two zeros. Okay, but in this case we have only one 0, so the other 0, it is assuming, we can assume that it is in the infinity, like that. Okay, hope that concept is clear to you. Okay, now we have a arbitrary diagram of our locus, just an arbitrary diagram. Now we can know, so our locus must exist, I mean our breakaway point, this point is present after -2, after -2. That means our breakaway point would be greater, or we can say should be after -2. Okay, should be greater than -2, or in terms of magnitude if you take. Okay, all right, so let us proceed and find how the procedure for finding the breakaway point is. What we have to first find the characteristic equation. For this, let me first do the closed loop transfer function. Closed loop transfer function is given by g of s divided by 1 plus g of s into h of s, and h of s is 1 here, so we can just take g of s divided by 1 plus g of s, that will be fine. So k into s plus 2 the whole divided by the denominator, I'm not taking it because it's going to get cancelled, and s square plus 2s plus 2, I'm just writing the simplified form of this, plus oh sorry, it would be, let's say k into, oh I was right only I guess. Okay, s square plus 2s plus 2 plus k into s plus 2. I am directly writing the simplified form of this. Okay, the denominator would get cancelled. This is the closed loop transfer function, and this is my characteristic equation. So let me simplify my characteristic equation and write s square plus 2s. Okay, let me have this way, but let me, okay, that is not a problem because we're going to take okay, let me not write it over here, we need to write it in the next slide, it's better. So the characteristic equation is s square plus 2s plus 2 plus k into s plus 2. Is it right? Okay, now I'm going to equate it to 0. The characteristic equation can be equated to 0. I'm going to take k to the other side, so s square plus 2s plus 2 equal to minus k into s plus 2. So now what is k? So k is equal to minus s square plus 2s plus 2es plus 2, the whole divided by this one, s plus 2. Okay, till this it's fine. Now I'm going to say dk by ds. I mean I'm differentiating k with respect to s. So it's a constant, so it becomes 0. So which is equal to the whole thing. Differentiation of the numerator is it's minus. I'm just having the minus over here, and then 2s plus 2 into s plus 2 minus s square plus 2s plus 2. Differentiation of this will be just 1, denominator is 1, so then s plus 2 the whole square. So this is the differentiation of this fraction. I'm just using the UV method to differentiate it. So this minus into minus, 0 would be minus, so this minus is anyway of no value. So I can say this can be equated to 0 equal to 2s square plus 4s plus 2s plus 4 minus square minus 2s minus 2 whole divided by square plus 4s plus 4. So is there anything getting cancelled? Or let's simplify this minus 2s, this going to get cancelled, and then you get s square, we just got 4s plus 4s, and then we have 4 minus 2, it's going to be plus 2 whole divided by s square plus 4s plus 4. Okay, this is equal 0, so I can take this denominator and equate it to 0. So what we are left with is, let me just put it on the top, s square plus 4s plus 2 equal to 0. From this we can find the s, right? So you can say minus b plus or minus root of b square would be 16 minus 4 into a into c, 4 2s are 8, divided by 2 8. So this is going to be minus 2 plus or minus root of 16 minus 8 is 8, root 8 be 2 root 2, divided by 2 will be root 2. Okay, so we are getting s equal to minus 2 plus or minus root 2, and the value of root 2 would be, value of root 2 is 1.414. 1.414. So if I add this minus 2 plus 1.414, and you will get minus 2 minus 1.414. So we will get this as this one is 3.414, minus 3.414. This would be 2 this would be 0 point something, right? 2 minus, or this would be 0.585 something that. So see, now let us see where these 2 points located in our locus. One point is 0.5 somewhere here, right? Somewhere here. The other point is on some, okay, the other point is somewhere here after 2. So that would be the right point, because the breakaway point is coming here, cannot come here, it's impossible. So this would be the right answer. So what would be the right answer? So this would be the right answer. So the answer for this question is minus 3.414. Okay, it's not a big calculation, I just went through step by step, and so it looks lengthy and like time consuming, but if you know the steps, you can directly do it and solve it in 2 minutes. Okay, thanks for watching.